Now we are going to discuss about Bose-Einstein condensation. People involved in it. This was first predicted during 1920s, derived originally from Satyendra Bose's work on statistical mechanics of photons and later extended by Sir Albert Einstein. The discovery process of Bose-Einstein condensation. During 1920s, Bose worked on how groups of atoms behave. Photons belong to one of the two great classes of submicroscopic particles, defined by whether their quantum spin is a non-negative integer or an odd half integer. The former type, called bosons, include photons, whose spin is 1. The latter type, called fermions, include electrons, whose spin is half. Einstein extended Bose's work to show that at extremely low temperature, bosonic atoms with even spins could coalesce into a shared quantum state at the lowest available energy. The requisite methods to produce temperatures low enough to test Einstein's prediction did not become attainable, however, until 1990s. The concept behind Bose-Einstein condensate. At this low temperature close to absolute zero, the atoms hardly move relative to each other. They have almost no free energy to do so. They become identical, and the whole group starts behaving as though it were a single atom. As the momentum and the kinetic energy reduces when atoms cool down, they get close to a certain value. So, as momentum and kinetic energy reduces, position of atoms becomes more uncertain, according to the famous Schrodinger wave equation, which says that the product of momentum, uncertainty in the position, and the uncertainty in the kinetic energy momentum is bound to a certain value. Hence, if uncertainty in momentum decreases, then uncertainty in position increases, and vice versa. The definition of Bose-Einstein condensate. It is a state of matter of a dilute gas of bosons cooled to a temperatures very close to absolute zero. Under such conditions, a large fraction of bosons occupy the lowest quantum state, at which point microscopic quantum phenomena, particularly wave function interference, become apparent. The transition to Bose-Einstein condensate occurs below the critical temperature. The critical temperature of a substance is the temperature at and above which vapor of the substance cannot be liquefied no matter how much pressure is applied. Now we discuss about the preparation of Bose-Einstein condensate. We start with a cloud of diffuse gas. Generally, rubidium is used for this purpose. We cool the gas collected with lasers using beams to take the energy away from photons. Since if we take energy away from the photon and the atoms, then a decrease in temperature of the atoms can be observed. But the second step can only decrease the temperature to a certain level. So for further decrease in temperature, we use an advanced method called as evaporative cooling. Now we discuss about the applications of Bose-Einstein condensate. It is used in the development of most sensitive detectors for precision measurement. It is used in the quantum information processing concept of quantum computer. Development of optical lattices which could be easily modifiable by varying interplanar spacing. This can be done by Bose-Einstein condensate. The other applications are: it is useful as a quantum simulator for investigating particles that have been predicted to exist by theory but too difficult to create or observe. Bose-Einstein condensate can be used to simulate a so far unobserved phenomenon known as quantum mass acquisition. Thank you.